So in this problem, we're going to solve a 2023 Aime I problem 4. So the sum of all positive integers m such that 13 factorial over m is a perfect square can be written as 2 to the a, 3 to the b, 5 to the c, 7 to the d, 11 to the e, 13 to the f, where a, b, c, d, and f are positive integers. Find a plus b plus c plus d plus e plus f. So if you already know the answer, skip ahead to the end of the video to see if your answer is correct. And if it's not, go back and watch the video. And if you find this video useful, make sure to comment, like, and subscribe. So let's just say m has to be a factor of 13 factorial, obviously, because 13 factorial over m is probably going to be an integer. So let's just say that m is equal to 2 to the power of x times 3 to the power of y times 5 to the power of z times 7 to the power of x1 times 11 to the power of y1 times 13 to the power of z1. So we know that 13 factorial, we're going to need that prime factorization. So 13 factorial, if we prime factorize that using Legendre's formula, the number, I'm going to create a different video covering what Legendre's formula even is, but that can be written as 2 to 13 factorial can be written as 2 to the 10, and that 10 is from 6, which is round down of 13 over 2, plus 3, which is round down of 6 over 2, plus 1, which is round down of 3 over 2. So that's 10. And so you do that same thing. You'll get 3 to the 5th. And it's 5 because round down 13 over 3, which is 4, plus round down to 4 over 3, which is 1. And then it's 5 to the 2. Same thing. Round down to 13 over 5, which is 2. Times 7 times 11 times 13. Okay, so now we know what 13 factorial is. So now let's just divide 13 factorial by m. That's going to be equal to 2 to the 10 minus x times 3 to the 5 minus y times 5 to the 2 minus z times 7 to the x1 7 to the x1 minus 1 minus x1 times 11 to the 1 minus y1 times 13 to the 1 minus z1. So now that we have this, I encourage you to pause the video and try to solve the problem from here. And so basically, we know that this number right here, it has to be a perfect square because that's what the problem says. So if it's a perfect square, we know that all the exponents are even. So 10 minus x is equal to even. 5 minus y is equal to even. 2 minus z is equal to even. And so on. And we know that 1 minus x1 is even. So then we know that x1 is equal to 1. It's the only possibility. And same with y1 and z1. Okay, so let's just basically, if we go back to the question, we'll see that we're asking for this. So let's go and see that we can just factor out a 7 times 11 times 13 because that's going to be in every single positive integer m. And we just have to sum the 2, 3, 5. So basically, so what about x? X can be 0, 2, 4, 6, 8, or 10. Y can be 1, 3, or 5. And z can be 0 or 2. So let's just see, and the sum of divisors formula, we can quickly cover that. So this formula is really helpful for this problem. And what it is that sum of divisors formula is, say you have a question asking what is the sum of the divisors of so rather than adding them out like that, there's a neat trick that you can use involving the prime factorization of 60. So 60 is 2 squared times 3 times 5. So the trick is, instead of writing this all out and finding the answer for that, all you have to do is multiply 1 plus 2 squared times 1 plus 3 times 1 plus 5. And that's just going to be the sum of the divisors of 60. Okay, so now we're going to try to apply that to this problem, except instead of the sum of the divisors, it's the sum of the square divisors. So instead of doing like 1 plus 2 squared, we'll just do 1 plus 2 squared. So basically, here, instead, we'll do times 2 to the power of, since x is for the 2 to the power of 0, plus 2 to the power of 2, plus 2 to the power of 4, plus 2 to the power of 6, plus 2 to the power of 8, plus 2 to the power of 10, times, and then here we have 3 to the power of 1, plus 3 to the power of 3, plus 3 to the power of 5, and here we have 5 to the power of 0, plus 5 squared. Okay, so if we multiply these all together, obviously we have d is equal to e is equal to f is equal to 1. And if we sum that up, we'll get 1 plus 4 plus 16 plus 64 plus 256 plus 1024. These two terms sum to 1280. These two terms sum to 80. These two terms sum to 5. So it's going to be 1365 for that. It's times 7 times 11 times 13. Well, actually, we don't know that d is equal to e is equal to f equals to 1, because some of these terms might have one of those factors. Times, and then this is just 3 plus 27 plus 243. So times 273, and then this is obviously just 26. So if we find the factors of this, we can break this down into 5 times 13 times 3 times 7. So if we break that down, that's what we'll get. So, and if we break down this, we'll get, it's going to be 13 times 3 times 7. And if we break down that, that's 13 times 2. So then our number will be, so we have one factor of 2 to the power of 1. So we know that a is equal to 1. Also, it's going to be 3 to the power of 2. So these factors. So b is equal to 2. And we're going to have a factor of 5 here. So 5 to the power of 1 times 7 to the power of 3 times 11 to the power of 1 times 13 to the power of 4. So that's sum is going to be 1 plus 2 plus 1 plus 3 plus 1 plus 4. And that turns out to be 12. So notice that this problem is for the Aime I. So you'd write 0, 1, 2. And that's our final answer. If you have any questions on how to solve this, except for Legendre's theorem and the sum of divisors, feel free to leave them in the comments and I'll do my best to answer them. That's it for this problem. Make sure to subscribe and like. Bye.